So in Python, dictionaries have a very specific syntax and behavior. They're very easy to use and very flexible at some level, but then they also kind of hide some details. It's a little bit hard. So it's going to be worth walking through these at just this conceptual level to see the syntax and some of the nuances inside of it. So I can predefine a dictionary up front by putting values inside of it. I can also build an empty dictionary just by using empty curly brackets. But if I want to add values to it right away, I do that by putting in key value pairs. So the curly brackets indicate you're talking about a dictionary. Just to be aware, the curly brackets could also mean you're talking about a set. So by default, dictionaries get the preference over set. You can always set a set by putting the word set inside of there. We'll see that when we get to code practice later on. But dictionaries can be dictionaries are the preference, but dictionaries or sets might be the curly brackets. But the key value pairs then are separated by the colon. Uh, there's just two data items. So in this case, it's a number and a string. It could be a string and a number. It could be a string and a string. It could be a number and a number. Doesn't really matter. It could be a number in a list. It could be a number in a set. It could be a number in a map. They're just two different items. The key has to be something that fits into a hashable item. So you can't use, I don't think I ever seen a list or a set being used as a key. I don't think that'll work. Um, but I don't know why you would want to anyway. So um, the commas then separate each individual item that goes into each entry that goes into the set. So the items are called the key value pair. So 23 Michael Jordan is one item, 13 Wilt Chamberlain is a second item, and go on and for there. Now this dictionary essentially talks about the player's number and the player's name. And this has some interesting ramifications we're going to see in a second. But if I want to know who was 23, it was and always should be Michael Jordan. He should have retired his number across the league, but that's a different political discussion about sports. Um, so if you want to get the value from a set, it's actually quite simple. There's two options. You can either use it like the dictionary the dictionary method, like the list method. You just put it in brackets, and so any key can go inside of here. So if you have a dictionary, it doesn't just have to be a number. You can actually put a string inside of here. Anything that is the key can go inside of here for a dictionary. Or I can use the call to the get method. So the players.get is this dictionary method that does the same thing. These two lines are absolutely the same. There's no real difference between them overall. They do the same thing. So the by the way, if you don't know GOAT here, it's actually greatest of all time, and that's a little subtle dig at basketball players that I am of the belief that Michael Jordan was the greatest basketball player of all time. But if you're not into sports, I'm sorry for the analogy. It just works well as a great little way of talking about keys and values, and we'll see as we go in a second. So I can add to a dictionary quite easily by using the same syntax here. So just like we did in the list, I can add to a dictionary by saying the player of number 24 is now set to be Kobe Bryant. Um, there is no add, there's no append, there's no put, there's no method like that in Python for increasing, including additional key and value pairs into a dictionary. I just simply use the key and then assign the value in this format. So it's hard to tell the difference between lists and dictionaries to some degree, but it's not important. I'm just adding the thing inside of this. So this will not just, so if 24 didn't exist in the dictionary before, it now does. It doesn't matter. I can do more than one at a time by merging dictionaries, if you will, with the update command. So in this case, I say number 7, Pete Maravich, and number 33, Kareem Abdul-Jabbar, update, and then whatever was in the dictionary players stays there, and then it adds in more players to that dictionary. I end up with basically twice, not twice as many, but the only way then to add is to assign, but I can do an update to do more than one. But it has to be coming from dictionary. I can't do an update with a key value pair. I've got to at least put it inside of another dictionary, and then it blends the dictionaries like this. So I could do a dictionary of one and do an update with that, but it's just as easy to use the syntax up top. But you have to watch out when doing this, because when I assign something, it will replace existing values that are there. So for example, when I first run this code, it says Michael Jordan 123, Wilt Chamberlain 113, Magic Johnson 132, and then notice here Larry Bird wore 33, and Shaquille O'Neal wore 34. So then I run the lines of code inside of here: 34 Charles Barkley, Pete Maravich, and Kareem Abdul-Jabbar, and do the update. Well, when I print this out again afterwards, notice I've added in some values here. I've added in Pete Maravich. I've added in Kobe Bryant from the code I did before. But notice Larry Bird and Shaquille O'Neal are gone now. They've been replaced with Kareem Abdul-Jabbar and Charles Barkley. So each key is in a dictionary one time and stores one value. So if my question is, who are all the players who ever wore 33? My key would be a number, and my value would be a list of strings, not a single string. But so long as it's key value like this dictionary can only tell me who is currently wearing this number. So if I want to talk about active players, what players are currently wearing the numbers, this dictionary works great. If I want to know historically or who the greatest players are that played that number, that wore that number, this data structure wouldn't work. So it's okay. We can just change the dictionary definition. We can just change it slightly. We'll see examples of that through the rest of this week, this content. But just know that this is the behavior of what dictionaries do. They replace values if you don't build them manually. So within the dictionaries, then we can also easily use loops. This first one here shows you how I can loop through the keys in the dictionary. So if I say for some variable in a dictionary, for number in players, it gives me the keys by default. I can also use that to get to the values. So I can say for number in players, and I can say that to get the actual player name, the value, I just say players of number. So we can see this syntax right here, players of number, gets me to the value. Or I can go straight to the values itself. I can ignore the keys if I don't care about the keys and just say, what are all the values in this dictionary? Well, I can just say for player in players.values. So there's keys, there's values. So we can see up here, players.keys is the same as just saying players in this case. But there's keys, there's values, and then there's items. And so the last one down here, we can see for number, comma, player in items. So the number is the key, the player is the value in items, and then I can use those variables distinctly. I can have both the key and value at the same time. But again, the syntax of loops in Python is really convenient and works really seamlessly with not only lists, but also dictionaries. If you need to remove something from a dictionary, like hey, I put player 13 as Tony Lowe, that's a huge mistake. I'm not a classic great basketball player. I never wore number 13 in the NBA. Well, what I can do then is I do what's called a pop. The pop removes both the key and the value from the dictionary. And you notice it doesn't matter what the value is. I just say pop 13 and it pulls both of them out of the dictionary. It's not there anymore. So really what this week is going to be focused on is using dictionaries to solve problems. And the next exercises and the couple videos get you set up for the exercises is really about how do I cleverly design a dictionary to answer a specific question. And that's about how do I define the key to track the thing that I want to sort my data by, and the value to store the answer to the question that I want it to be. Now, if I want to know how many robins were in a data structure, I could just search and say, count each robin, as for the bird sighting example we talked about before. But particularly dictionaries are good when I want to count all of the various different types of birds, and I don't even know what types of birds are available until the application goes and runs. So dictionaries are really good at open-ended, complex problems, but bounding the problem in a very useful way that doesn't require us to write a bunch of complex code, but does have us do some complex planning ahead of time. And that's really what this week is about, and is harder to do to some degree because it's not about the rules so much as it is the patterns of solving problems. And so definitely give these problems a try. If you're not sure where to go, then reach out for help and ask. But the next sets of videos here are going to introduce you to some of the problems for this week's work. So check those out and get started, and then let me know how I can help.